Hello, students. Welcome to Lesson 7, Infinite Decimals. So we are going to develop an intuitive understanding of the placement of infinite decimals on the number line. So you're going to see a number line and you're going to go, okay, this decimal belongs here. And then you're going to develop an argument for believing that 0.999 repeating should equal 1. All right. So decimals are like regular numbers. We can have an expanded form. So if I had 3,765, that would be 3,000 plus 700 plus 60 plus 5. So the decimal is the same thing, only it's over the powers of 10. So 0.3765 would be, if I said it, would be 3,765 ten thousandths, which would be 10 to the fourth because there's 4 zeros in 10,000. So I can write that as 3 over 10 or 3 tenths plus 7 over 10 times 10, which is 7 over 100, plus 6 over 10 to the third, which is 1,000, or plus 5 over 10 to the fourth, which is 5 over 10 to the 10,000ths. So if I add those up, that's my decimal. But this is called a terminating decimal because it ends, right? It goes 3.765 and that's it. It's done, over, finished. We also have repeating decimals, 0.333333, and goes on forever with threes. That's a repeating decimal. And we can write it in expanded form. 3 over 10 plus 3 over 10 squared plus 3 over 10 to the third plus 3 over 10 to the fourth, etc., etc., etc. And we could just go on forever. So these three dots at the end of a repeating decimal mean it goes on forever. Now, when I was a kid, we would put a line over the number that was repeating, but on computers and typewriters, that's really hard to do. So they just use three dots most of the time now. So if you see three dots or if you see a line over a number, that means the number is repeating. The big advantage with a line over it is you can specify exactly which numbers repeat, because sometimes you have fractions or decimals with a number that doesn't repeat and then numbers that do repeat. So sometimes the three dots can be confusing, right? So let's take a look at these two numbers on a number line. So 0.253, remember that would be like 2 over 10 plus 5 over 100 plus 3 over 1,000. So if I go to my number line and I go between 0 and 1, that's where the 0.2 is. So 0.2 is at the second slash. Then if I take the points, this part of the number line between 2 and 3, and I expand it out into 10 spots. So between 0.2 and 0.3, 0.25 is right there. And then if I take this spot between 0.25 and 0.26 and I zoom in on that, 0.253 is this part right here, the third spot. So it's on the second hash, and then I zoom in on the fifth hash, and then I zoom in, and that's on the third hash. So basically, I've zoomed in between 0 and 1, and I've broken that number line into 1,000 little pieces, and I took the 253rd piece. Okay. So took 0 and 1, broke it into 1,000 pieces. Now, on a regular number line, between 0 and 1, there's 10 dashes. And then if I went from 0 and 1, broke it into 100 dashes, here's 100 dashes. And if I broke it into 1,000 dashes, you can't even see the initial dashes. So sometimes a decimal is better than the number line. Okay. So it's like the 253rd little dash between 0 and 1, but I cannot even see it. But I could expand it as 2 over 10 plus 5 over 10 plus 3 over 1,000, or 2 over 10 plus 5 over 10 squared plus 3 over 10 to the third. It's a terminating decimal. It ends. This is the whole thing. We're done. we have repeating decimals, like 5 over 6. Okay, this repeating decimal is equal to 0.83333 repeating. Now here's where the line would come in handy, because I could write this as 0.83 with a line over 3, and you know the 3 repeats, but not the 8. If I put a line over the 8 and the 3, it would repeat as 838383. And there are decimals that do that, but not this one. All right. So if I expand it out, I have 8 over 10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10,000, etc. It just goes on and on and on forever, and we can't actually get to the exact spot, right? So with the 2.53, I zoomed in, I had an exact spot. But 0.8333 is repeating. So I've got the 0.8 is here, but 0.83 is just a little to the right of it. And if I break that in, 0.83 is here, but 0.833 is right there. And the next one, 0.833, would be here, but 0.8333 is here. And I can keep going on this because my threes, I keep adding a 3 on the end. So every time I zoom in to my number line and multiply it out by another 10, my decimal is just a little bit to the right of whatever that hashtag is. But it's always just a little bit to the right of this hashtag. So it's a nice pattern, but I can't really nail down the exact hash mark that it's on, right? So the repeating decimal has a nice place on a number line. It's just every time you zoom in, you find they end up finding a spot between two hashes. And though to be fair, it's always the same spot in between those two hashes, the difference between a rational number and an irrational number. For a rational number, when I zoom in, it's always like it's always at that spot between the two hashes, right? So it's always just a little bit to the right. This number is always just a little bit to the right of the hash. An irrational number would bounce every time I zoom in. It might be here, it might be there, it might be somewhere else. It would always be between the two hashes, but every time I zoom in, it would be in a different spot. So this is a rational number because it still has a pattern. And it also gives us really interesting things. So 0.999 repeating. So in math, it's actually equal to 1. And it really took me a long time to learn this. So I look at 0.9999 and I go, okay, every time I go in to another 9, that's not exactly 1. And I zoom in and it's always a little bit off from the 1. But it's a fraction, right? So if I think about 0.999 repeating, that's like 0.33 repeating plus 0.3 repeating plus 0.3 repeating, right? 3 plus 3 plus 3 is 9. And if I'm repeating all of those, that's 0.3999 repeating. But as a fraction, 0.3 repeating is 1/3. And if I add up 1/3 plus 1/3 plus 1/3, I get 3/3. And that's actually 1, right? 3/3 is 1. So really, 0.999 repeating is actually equal to 1. It's a weird thing about repeating decimals and fractions and rational numbers that doesn't really make sense, but is true. All right, so summary of this whole lesson, repeating decimal is always somewhere between two hashtags on a number line. Every time I zoom in, it's just a little bit between two hashtags on the number line, but it's always in the same spot. So sometimes it's better to have that as a fraction. And repeating decimals lead to weird things like 0.999 repeating actually being equal to 1. All right. So that's our lesson. It is optional. Try the homework if you'd like to, ask questions, and then let's move on to lesson 8.